Alrighty, so we are going to go over a few questions that you guys posed for me for the chemistry test. Uh, One of the things that I do want to mention is on my agenda. You should still be checking my agenda every day. This is how you know what's going on. But I'm going to go over here to my agenda, and you see here for May 11th, I have a little welcome back video that I have posted. I have the study guide. Complete set of notes. I have a link to the complete set of notes. And when I click on that complete set of notes, then I have over here, this is everything that you need to review. And I would keep this particular copy handy. You might have your own notes that you're using that you kind of filled in the blanks, but this is my complete set of notes and it should match exactly what we learned about. And then you will see down here at the bottom that the two graphs. It's kind of hard to do with your version of the notes, but in an exothermic reaction, you start with the amount of energy of the reactants. We go up to the activation energy, and it goes all the way down because it releases energy. Endothermic, we start with a certain amount of energy. We increase it for the activation energy, but then the products end up with more energy than the reactants. So that's what that graph is showing. So you want to review that. So I had you guys pose some questions to me, and some people asked some questions that not necessarily test related. This video is about answering questions for the test. Questions such as, how many questions are there and how much is it worth and everything else like that. And, I have a way of doing things, and this test is going to be worth 100 points, just like every other test that we've taken so far. It is had a question, would it be the same if we were in school? And the questions are all the same that we would be in school. The only real difference is that there's fewer questions than what I would be asking you if we were in school. I took a look at that, and I took it my old test that I had when I was making the Google form with the test up, and I just didn't use as many questions for a variety of reasons. One is just so it doesn't, you're not involved in taking the test quite as long a period of time. For example, when we get to balancing equations, I think I might have 3 questions that involve balancing equations. And, when we did the test in school, last year's class, when they took the test, they might have had a few more questions. So things like that is just a little bit shorter, but all the material, the notes are the exact same. All the material covered on the test is the same. It's just some questions might not necessarily be repeated a little bit. So, well, let's get started here. And the first question that I want to address here is, does exothermic reactions give off heat or absorb heat? Well, to answer this question, you got to look at the prefix. The prefix exo as opposed to endo. Exo, like in the word exit, when you go through the exit of a building, you're going out of the building. So that means in an exothermic reaction, energy is going out of the reaction, as opposed to an endothermic reactions where endo, like an entrance, you're going in. So exothermic energy is going out, and so it's giving it off. As opposed to, if you imagine a sponge absorbing water, water is going into the sponge. So endothermic energy would be going in or absorbing it. Exothermic reaction, heat is being released or it's given off. Great question. All right, let's see what we got next one. On the chemical reaction study guide, it says the blank and the blank of electrons determines the blank and blank of the properties of the elements. So the number and arrangement of electrons. If you remember way back in October, we drew atoms, and it was based off of the periodic table and their electron arrangement. And the thing is that if they had that outer energy level of electrons, only ever contained up to 8 electrons. It's what we call the valence electrons. And if they had 1 or 2 or 3 electrons in the outside, the atoms would tend to lose those electrons, become positive, and those were mostly metals. Whereas the elements on the right of the periodic table, they would have 6, 7, or 8 valence electrons, and they would tend to gain electrons and become negative when they gained electrons. So the number and kind and arrangement of electrons, how many they had in the outer side, that determined the physical and chemical properties of the element. And so moving on here, could you review dependent and independent variables? That's a great question. I know it was on my study guide, and honestly, I think those are some of the questions that aren't involved in the test. But that doesn't mean I won't review this question for you, okay? The independent variable starts with the letter I, and if you are the scientist, you would say, what am I doing as a scientist? What do I change as I am completing the experiment? And this is what you do in your procedure. So what you change, the independent variable is the factor that you change. It's what you're trying to test. Imagine if you were doing an experiment and you wanted to see what substance plants grew best in. And so you had soil and you had rocks and you had sand and, maybe you just had some wood and you had some paper and you had some marbles, just a whole bunch of different substances, maybe each of them in their own cup. And you put a seed in there and everything else you kept the same. But that thing that you changed, the type of material that you're trying to grow the seed in, that would be your independent variable. Dependent variable is the results that you get. So the fact that plants grow in some, plants don't grow in others. Some of them, the plants grow better. Some of them, the plants grow worse. Some of them, the plants grow the same. But whatever the results are, that is your dependent variable. The dependent variable depends on the independent variable. And it's D for determine. What are you trying to determine? The results is what you determine from that. Okay, great question. We can always use that, and I ask those questions in the lab, so whether or not it's on the test or not, it's always good question. Here's one that says, what are all of the equations? Well, I'm not going to tell you all of the equations, but when we do get to equations, we get to balancing equations. And if you watched my welcome back video from Monday, May 11th, I think today's the May 11th. If you watched it from Monday, May 11th, I did give you a teaser that I was going to give you a test question. So here it is. All right. This right here is a test question. And actually, I'm going to pull up the test right here that you're going to see this. And it says, identify if the following equation is balanced or unbalanced. Here's the equation. And then the answer choices are balanced or unbalanced. Okay. So, what we need to do is we need to determine if this equation is balanced or unbalanced. So the examples that I showed you, what I like to do is I like to write it out. So when you're taking this test, don't just figure it out on your own, but go ahead and write it out on some paper. Keep some scrap paper for you to take this test, write it out. Keep in mind that every time you have a capital letter, you have a new element. If you have a lowercase letter like you do with the G, it gets paired with the A, and that's actually silver, the silver atom. Not that you need to know silver per se in this, but that's what you have. And so what I like to do is I like to write it out and I like to count the number of atoms. That's step one, is to count the number of atoms on both sides of the equation. So wherever the arrow is, I like to draw a line underneath there, and then I list the elements as they appear. So I have Ag, and I listed Ag. I have H, I listed H. I have S, I listed S on the left, and then I recopied that same list on the right side of the equation for the three elements that I have here. The next thing to do is to count the number of atoms on both sides. So for Ag, you would look and there's no coefficient, so it's understood to be 1. There's no subscript, it's understood to be 1. So therefore 1 times 1 is 1. For the H or hydrogen, it'd be 1 times 2. And for the sulfur, it'd be 1 times 1. Keep in mind that this 2 here only applies to the H. The subscript only applies to what it immediately follows. Going over to the right side, Ag would be 2, S would be 1, and the H would be 2. So if I go to the next slide, I have those listed here for you. So I've counted the number of atoms. So now the question isn't balance the equation. It's, is the equation balanced? And so really, we don't need to go all the way to the end to balance this particular equation. All we really need to do is step 1, which is to count the number of atoms on both sides of the equation, and then do a little evaluation of it. And that is it balanced? Well, when we do the comparison, there's 1 Ag on the left, 2 Ag on the right, 2 H on the left, 2 H on the right, 1 S on the left, 1 S on the right. And so when just comparing this, we see that there's 1 silver, 1 Ag on the left, 2 on the right, that's not the same. It's unbalanced. So your answer is unbalanced. Now, if we were to, if it would be 1 and 1, or say it would be 2 and 2, 2 and 2, 1 and 1, well, then it would be balanced. It'd be a different answer. But if you were to continue, you would look at that and you'd say, okay, well, what do I need to do? Well, I'm going to look at this 2. I have 2 Ag on the right. I have 1 Ag on the left. So I'm going to multiply Ag by 2. So I put a coefficient of 2 here. And that only goes to the Ag because of this plus sign. It kind of breaks it up. And so I cross off the 1 and I put a 2 there. And now I have 2 and 2, 2 and 2, 1 and 1. And so it's a balanced chemical equation. And so that's what you would have to do. So for the questions, because they're multiple choice with balancing equations, you are going to determine if the equations are balanced or unbalanced. And if they're unbalanced, well, then you know that answer. If they are balanced, you do that. But you don't really have to go all the way to balance the particular equations. It's just the nature of the multiple choice questions that we have. Okay, here's a question. If the substance happened to produce a plasma-like exposing aluminum foil to microwaves, would it be a chemical or physical change, or both? Well, it's a great question. I found this little video here. And so what they have is inside this microwave, and oh, by the way, don't try this at home. But they got a little bit of aluminum foil here, and it's inside the microwave. And let's just play it here.
This aluminum foil, and I was actually able to get it to work.
So you see that big bright blue light, and there should be a plume near the top. Let's see if I can stop it right there. See that plume near the top? That is the plasma that's created. Now, the guy that created this video went on to say that a lot of these plasmas, like the blue, if you recall the flame test experiment that we did way back in October, where we burned different compounds and they burn different colors, that's because different elements have different amounts of energy. And so what you have with this particular thing, the microwave puts energy into the aluminum foil, which is a metal. And this is why they tell you not to put metal in the microwave, because what happens is the metal conducts electricity, and so it takes that energy and it just holds it back in, and it doesn't actually vibrate like it would for your food when it's cooking your food. And this is why you don't want the fire in your microwave, because then you have to buy a new microwave because you ruin the microwave, and that's not such a good thing. But in this case, initially, that some of that aluminum is converted into plasma. And keep in mind that even though we only typically study the 3 states of matter, solid, liquid, and gas, plasma is that 4th state of matter, which is at a high energy state. And it turns out that aluminum in that high energy state is blue. So that is initially, it's just energy into it, kind of like melting an ice cube. You put energy into it and it goes from a solid to a liquid. Going to the plasma, it just initially makes it into a physical change because it's a state change. And state changes are physical changes. Okay? So if you're asked questions like if something is melting, think of things that melt. A candle wax will melt. We had that in the one lab. Ice cubes will melt. Rocks melt into lava inside of volcanoes. All those things are physical changes. And remember, a physical change, it's something that can easily be converted back, and it doesn't change the substance. So think about lava. The rocks they become molten inside the volcano, and when the lava comes out and it pours out over the ground, once it cools down, it forms back into rock. Now, some of that stuff might be rearranged, but essentially, if it was a monolithic substance, meaning it was all made of the same rock, then you're just going to produce the same rock again. So initially, this blue plasma is aluminum, and it's aluminum plasma, which is just a physical change. But play us just a little bit,
that it made was a nice blue.
And right there, see it gets yellow. And that yellow is actually a chemical reaction with the plasma, reacting with the nitrogen and the oxygen that's in the air. Keep in mind that when we breathe in, 78% of what we breathe in is nitrogen, 21% oxygen, 1% carbon dioxide, and then just other gases. And so what happens is that the nitrogen and the oxygen actually combine to form a chemical reaction that form nitrous oxides, which is a component in acid rain. And so energy forms that nitrogen, oxygen, forms a reaction, And of course, oxygen itself is the ozone that's in the air, which ozone is actually O3. It's not oxygen, or oxygen actually is converted. That energy is actually converted into ozone. So ozone is in the air, but mostly what we breathe in is O2. Ozone is O3, and that's a chemical reaction to get it to change because it's got a new chemical formula as well. So the combination of the nitrogen and the ozone forming the nitrous oxides is what's producing that yellow light there. And so that plasma, because it's at a higher energy state, is causing the air to react. But the initial reaction is just converting it to plasma begin. Is just a physical change. So that was a great question. Had a little fun looking that up. When I go to favorite pizza toppings, we had a number of answers from bacon and pepperoni and chicken bacon ranch. And somebody said they didn't like any pizza topping, which to me seems like your answer would be cheese. And we had a number of people with cheese, peppers. There was a lot of good answers. I of course like the supreme. I just throw it all on there. It's a good combination, but you can't go wrong with bacon. And we had a forum actually a couple weeks ago, signs of reaction. And I asked you guys a question. I said, why is it not good to tell secrets in a cornfield? And of course, the answer was that there's too many ears, right? And some people posed me questions how I'm doing. I appreciate you asking. I'm doing great. We're moving along, doing what we got to do here. The end of the year is real soon. I want you to give a real good effort on this test. And do your best on it. Like I said, have the notes available to use that. Have a blank sheet of paper to use that as well, and to write out the equations, to do what you got to do to do a good shot at that test. Otherwise, keep up. The next section that we have is going into energy, and we do a button and string activity on Friday. Hope you guys enjoy that. Maybe you can do that yourself. And I enjoy some of those Rube Goldberg machines that are coming in. I was looking at some of them today, and they're looking good. So have a good one. Good luck on the test.